It's Thursday, the 2nd of January. My name's Juan Brown. You're watching the BLANCOLIRIO channel. And not a whole lot of updates yet on the JEJU 737 crash that occurred in Muan, South Korea a couple of days ago. Now, a lot of folks are speculating that maybe the crew shut down the wrong engine in this accident, causing them to have to come around and do a forced landing very quickly. But we don't know that, we won't know that until we get the cockpit voice recorder and the aircraft data recorder, and we do have some updates on that. From Simon Radecki's Aviation Herald, both the data recorder and the cockpit voice recorder have been recovered. However, a key connector is missing from the flight data recorder. So the flight data recorder is going to go back to the NTSB in Washington, D.C., and there I am confident that they'll be able to download the data off of the aircraft data recorder despite the broken connector. Regarding the CVR, the cockpit voice recorder, that data has been downloaded already. Of course, that information is not being published yet as investigators are still checking it out. But what we do have now is a much clearer understanding of this very tight timeline of events. At 08:54 local time, the Muan Airport Control Tower clears the aircraft to land on runway 01, so they're doing a straight-in approach to the north. At 08:57, the ATC advises them of bird activity in the area, not uncommon, a very common radio call. At 08:59, the pilot reports a bird strike, declares Mayday, 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 bird strike, go around. 1 minute later, they initiate the go-around and request authorization to land on runway 19, the opposite direction. 2 minutes later, the tower gives them permission to land on runway 19. Just 3 minutes after declaring the bird strike, the aircraft touches down on the runway 1,200 meters down the runway, or 3,940 feet, a good ways down the runway 19, with no gear and no flaps, and a very smoking fast speed. 34 seconds later, the crash bell is sounded, and 55, less than a minute later, the aircraft fire and rescue unit completes deploying the fire and rescue equipment. So just 3 minutes from the time that the pilot declared Mayday, Mayday, Mayday until they hit the runway, indicating this aircraft just simply whipped it around and came around and landed in the opposite direction just about as quick as they possibly could. Now, there's several diagrams out there showing the direction of the flight. Some of them show a right base entry. Some diagrams show a left base entry. We don't have the actual data as to how they actually turned onto runway 19. I only bring this up because if you're sitting in the right seat, it's easier to do a right base entry because you can clearly see the runway out your right window. If you're in the left seat doing a right base entry, it's much more difficult to do that. Visually, you can't see as good across the cockpit. Same thing with a left-hand base pattern turn. That's why all standard traffic patterns are to the left, because in two-seat aircraft, the captain would be flying in the left seat. And again, we don't know who was flying the aircraft at the time that the landing was made and who was flying the aircraft at the time that the approach was being made. And some of that may be bared out in the cockpit voice recorder, but a left-hand pattern entry is easier if you are operating the aircraft from the left seat. So just 3 minutes from bird strike to crash landing indicates to me that the crew had absolutely no time to do any of the emergency checklists and barely any time to even get any of the normal checklists done, like lowering the gear and lowering the flaps. Now, there's this interesting eyewitness observation. A ground observer reported that the aircraft flew through a flock of birds. 2 or 3 pop sounds were heard as if the birds were ingested into the engines. Flames were seen from the right-hand engine, and we've seen that video of the compressor stall coming out of the right-hand engine. The aircraft climbed a little but seemed to be unable to climb further and landed in the opposite direction. When the aircraft overflew the observer, it had the landing gear down. So the aircraft was configured for the straight-in approach on runway 1, and then they hit the birds, and the crew elected to do a go-around, thus raising the gear and presumably the flaps as well. Now, one observation in the comment section from a lot of the veteran pilots, and I agree with, is that you have a bird strike on final. You are cleared to continue that landing straight ahead even though you're now transitioning from a 2-engine normal approach and landing to a single-engine emergency landing, it's very easy to quickly transition to a single-engine approach and landing. Once you're all set up and configured, if you can remain on a stabilized approach, it might be a much safer bet to just continue on straight ahead and land the aircraft on the one engine or whatever engine power you have remaining, rather than attempting a go-around at that point. There's another interesting comment regarding the ADSB data. Remember, the ADSB data stopped right at 0858, just about the time that the bird strike occurred. And on previous flights, the ADSB data continued all the way to the ground. So it's not a problem with ADSB reception in the area that the ADSB data was lost. Was there some sort of an electrical problem that caused them to lose their transponder and thus stop the ADSB transmission of data from the aircraft? Let's take a quick review of the 737 electrical system. Quick review on the 737 electrical system. If you lose the number 2 generator, or number 2 engine, thus the number 2 generator, you'll have the bus tie contactors will provide power from the left AC transfer bus over to the right AC transfer bus. So in other words, generator 1 can power the electrical system on the right side of the aircraft. If you lost both generators, both engine-driven generators, on the 737, you're going to get power from the battery. They say about 30 minutes worth of battery power is available. This is assuming, of course, you don't fire up the APU. You can always fire up the APU and reconnect your electrical sources and get plenty of electrical power. Without the APU and without the 2 generators, you got the battery, and through a standby static inverter located right here, you can power the AC standby bus, and of course the DC standby bus will be powered by the battery, and you also have the battery bus and the hot battery bus, both the switched and the hot battery bus. So all those buses will be powered just by the battery alone on the 737 for about 30 minutes, unless you get the APU fired up, in the event of the loss of both generators. Remember, there's 2 transponders, a left and a right, and you switch them back and forth depending on which flight it is. If the transponder is in the number 2 position, it would be powered by I believe by the right AC buses. So if you lose that number 2 generator, your bus tie contractor is going to close, and you're going to get power from the left AC and continue to operate your transponder. But if you had lost both generators and you were on the number 2 transponder, then yeah, you would lose that transponder. But you have the option on the 737 next generation of aircraft to put your number 1 transponder on the AC standby bus. So if the transponder was in the number 1 position and you were down to just battery power, it would still be powered. So if you lost both generators on the 737NG, you can still operate the aircraft, you can still land the aircraft, and you can still operate the basic hydraulic systems. And here's a pretty comprehensive list of all the things that are going to continue to still operate. And on the instrument panel, of course, depending on which option you have, you'll still have the captain's flight instrument displays. You'll have all your standby instruments working, but the FO side will be blank. And here's the detail about the transponder. If you have this option, you'll have transponder number 1 operating off of the standby power. Transponder number 2 is out. Regarding the poorly designed localizer antenna off the end of runway 19 at Muon's airport, which apparently was designed so robustly in order to avoid getting flooded by the frequent typhoons in the area, here's some basic guidance that the FAA uses here in the United States for these sort of situations. When you're designing a runway, there's a lot of different definitions for a lot of different safety areas. There's the runway safety area, the obstacle-free zone, clearway standards, object-free areas, and stopway standards. And all these numbers and specifications vary depending on the size of the airport and what type of aircraft designs are going to be operating out of this airport. At airports like Muon here in the States, the recommended runway safety area is at least 1,000 feet long. And this runway safety area should generally be a relatively smooth area out for that 1,000 feet. And paragraph 4, free of objects except for objects that need to be located inside the runway safety area because of their function, like localizer antennas. But objects higher than 3 inches above grade should be constructed to an extent practical on a low impact resistant supports frangible mounted structures of the lowest practical height, no higher than 3 inches above grade. Now, regarding the location of localizer antennas covered by this reg, it's generally recommended that the localizer antenna be located just beyond the runway safety area or just outside of 1,000 feet. So on center line, but 1,000 feet, but more than 1,000 feet off of the end of the runway, but no more than 2,000 feet away from the end of the runway. So that gets it out of the runway safety area. But they realize that in a lot of different places, that's not possible. You got to put the localizer inside the runway safety area. And again, it's the same thing. They want that localizer antenna no higher, the foundation of that antenna, no higher than 3 inches above grade with a frangible or breakable that an aircraft can easily knock those antennas off if they're struck. Now, when measuring your runway safety area, sometimes it starts at the end of the runway, sometimes it starts at the beginning of a stopway. But here at Muon, according to this Google Earth dated photo, at the departure end of runway 19, or the approach end of runway 01, from the end of the runway to the concrete security wall, that's just over 1,000 feet. But the localizer antenna is located inside of that, just right at 862 feet or so, off of the end of the runway. And because of the frequent typhoons in the area, unfortunately, designers built apparently a reinforced concrete footing underneath this berm of dirt supporting the localizer antenna, with the frangible surface way up here at the top of the reinforced concrete berm. And unfortunately, most of these airports in South Korea apparently got to have this giant security fence because a lot of these airports double as military airports. And the Muon International Airport is extending its runway to the north. So still more questions than answers right now regarding this crash, but we'll get a lot more information and some pretty solid information once we get the data from the data recorders. Thank you so much for your support of this channel, especially the folks over on Patreon that make this content possible. See you here.